In section 24, we're looking at the rate of change of functions. So to do this, we have to understand what a rate of change is. The rate of change is how one quantity changes in relation to another. Now, we're always going to follow this pattern that when we have the rate of change, we're going to be looking for how the output of a function changes in relation to the input of the function. So the units of rate of for rate of change are going to be units of the range, which again is our output, thinking back to what we've already done with functions, over the units of the domain, which is our input. So when we're looking at questions like the model here in Activity 1, defining a rate of change, what we're trying to do is identify what is our input value and what is our output value, or variable in this case, the quantities that are going to change. So we have a climber is on a hike, climbing at a constant rate. His altitude is a function of the number of hours he has climbed. So right there, that sentence is going to define for us what the function is. The altitude is a function of the number of hours he has climbed. Our altitude is our output. The other quantity, the number of hours he has climbed, is our input. So I'm going to go ahead and label those as output and input, or O and I for short. After 2 hours, he's at an altitude of 400 feet, and after 6 hours, he's at an altitude of 700 feet. So what we want to do is three things. We want to find out what's the domain of the function in context, what's the range of the function in context, and what's the climber's rate of change. So to answer those first two questions, I'm going to just use the idea of the output and the input. We know that the input is the domain of the function. So here, what is the domain of the function? It's the number of hours he has climbed. So number of hours climbing. And the output is the range, so in this case it's the altitude of the climber. And when we want to find the rate of change, we're looking for how does the output change compared to the input. Well, to do that, I need some numbers. So I'm going to look for where I have some numbers, and if I have them, fantastic, I'm going to look to see if I have multiple sets of numbers. So here we have after 2 hours, he's at an altitude of 400 feet. And we also have another pair, after 6 hours, he's at an altitude of 700 feet. So we have two ordered pairs that we can use to set up our rate of change. So I'm going to write these numbers down. And when I write my ordered pairs, I'm going to write it as input, comma, output. So the input in this case is our time. So at this ordered pair, you have 2 and 400. There's my first input and output pair. I'm going to do the same thing for my next pair, which is at 6 hours and 700 feet. So that would be 6 and 700. Now to find the rate of change, I have to find how does the output change compared to the input. So let's take a look at what we have. The outputs are the second coordinates, so I'm going from 400 to 700, so that's a change of plus 300. And then I'm going to do the same thing for my inputs. From 2 to 6 is a plus 4. So again, rate of change is change in output over change in input. And I'm going to go ahead and put units in there as well, just to be mathematically correct. So we know that we had 400 feet to 700 feet. That is a 300-foot increase. And the 4 represents the number of hours. And then we'll go ahead and simplify that. So when we take 300 divided by 4, that's going to give us 75 feet per hour. And so that's the rate at which he's climbing the mountain. All right, and this one's kind of the same thing, so we'll skip to another one like this one, where sometimes we don't have two sets of ordered pairs. We still have a function, we still have an input and output, but not going to be quite so easy to calculate that. So the average temperature is a function of time. So I'm going to label that here, or highlight average temperature is a function of time. Over the last 50 years, the average temperature has increased by 2.5 degrees worldwide. The temperature changed at a constant rate. So we only have one set of ordered pairs that we can use. Actually kind of a change, not really an actual set of ordered pairs. Well, we're going to identify the domain and the range just like we did before, so not very different here. The domain is the input in this case, which again we've labeled time as our input. So this is time. And I'm just going to put in here in years so that we start getting used to the idea of units. And then my output would be temperature. And we're going to just say degrees. That's probably degrees Fahrenheit because that 2.5 degree increases would be significant if it was Celsius. So we want to know the rate of change in worldwide temperatures and include units in that. Well, again, we don't have two sets of ordered pairs. We just have one. We have that in 50 years, we have a 2.5 degree output or increase in temperature. So our rate of change is our output over the input, or the change in output over the change in input. The output's temperature, our change in the output was 2.5 degrees. And our change in time, in this case, was 50 years. So when we go ahead and divide those, and I'm just going to double check with my calculator here, divided by 50, I get 0.05 degrees per year. So that's my rate of change of the temperature over the last 50 years for the average temperature globally. So once we have these situations, now we can start applying and doing some other things with it. So we have a function here where we have a savings account. So Michael started a savings account with a certain amount of money. So when you open the account, you have to deposit a certain amount to even open that account. The amount in the savings account is a function of, so the amount in the savings account is a function of the number of weeks the account has been open. So we're looking at, again, an output and an input. And we're going to, again, grab some ordered pairs if we can to help us out. Again, we know that the input is the number of weeks, that's our domain. The output is the amount in the account, that's our range. So the change in money, we need two ordered pairs if we can have them. 4 weeks, 350, and 9 weeks, 400. So I'm going to write those ordered pairs. And 9, 400. And we're going to find out how much money was changing per week. So our output is a change of plus $50, and our input changes by 5 weeks. So then when we write our rate of change, it's going to be $50 over 5 weeks. So what that ends up giving us is $10 per week. All right, so on question 2, 3, and 4, we're basically saying, all right, now that we know that, now we know the rate of change, how much more is increasing per week, we want to know how much is in the account at 10, 11, 12 weeks, and so on. So I'm going to go ahead and figure this out using my one of my original pairs here, which is 9, 400. And just intuitively, if we go from 9 weeks to 10 weeks, we know that the change right there is a plus 1 week. So that gives us the 10. We know that every week we're adding $10. So if it's been 1 week, we would expect to add $10 to the account. So our $400 deposit, or balance I should say, not deposit, will become $410. So that's how much is going to be in the account after the 10th week. And we can do the same with the 11th. And I'm going to go back to that 9, 400, and you're going to see why in just a minute. I could go from the 10, 10, 410, but I want to go back here for a reason. So at 11 weeks, that's 2 weeks away from 9, so that's a plus 2. So that's 11 weeks, and that's what we're supposed to have. And again, $10 a week, 2 weeks, that's a $20 increase. So that's $420 that he'll have in the account at the end of the 11th week. And the reason I'm showing that is because in number 5, we're saying, okay, what about the 71st week? So it's not just easy like, okay, I'm going to keep adding 10 every week. I don't want to do that all the way up to the 71st week. So I'm going to go back to my point 9, 400. Again, it's a known point, so it's a good one to use. And from the 9th week to the 71st week is 62 weeks. And then if we're adding 62 weeks at $10 a week, 62 times 10 will give me 620. So in that span, I'm going to add $620 to the account. So then his final balance after the 71st week is 1,020. So again, we're using that rate of change and a known value to get future values or past values. So you just find the rate of change and then apply it to that original point.